To solve this limit to infinity problem, most teachers will want you to find the highest power on the bottom and divide every term by that power. So in this case, the highest power in this equation is x squared. So now we take every term and we divide it by that x squared. So it's going to be 3x divided by x squared minus 2 divided by x squared all over 2x squared divided by x squared plus 5 divided by x squared. We reduce everything as we can. So the top then, one, the x reduces. So this x reduces. So the first term, you just have 3 over x. The next term stays 2 over x squared. And then on the bottom term, x squared divided by x squared, that just gives you 2 plus 5 over x squared. And the key to simplifying this is that when you're plugging infinity in for x, any number that is divided by infinity goes to 0. The first term, we're going to plug in infinity for x, so 3 over infinity, this thing goes to 0. And the next one again is 2 divided by infinity squared, that also is 0. The two constants stay the same, 5 divided by infinity squared, so 5 divided by infinity squared, that's also 0, leaving you just numerator has nothing but 0, and the denominator just has a 2. Well, 0 divided by 2, then this limit just equals 0. Another way to quickly solve this problem is if you remember your old algebra rule for finding the horizontal asymptote, whenever the highest power is on the bottom of a fraction, so in this case we have x squared, and at the top you have x to the first, that would give us a horizontal asymptote at 0. As you recall, the graph will approach the horizontal asymptote as you go towards negative infinity and positive infinity. Therefore, finding the limit to infinity is the same thing as finding the value of the horizontal asymptote. For this limit to infinity problem, we do the same thing. We search the whole entire problem and find highest power. We see that the highest power is 2. And now we rewrite the problem, but we divide every term by that highest power. So be 4x squared divided by x squared minus x divided by x squared plus 3 divided by x squared all over 3x squared divided by x squared plus 2x divided by x squared minus 1 divided by x squared. Simplifying terms, you see x squared divided by x squared. The first term here, that's canceled out just 4. The second term, 1 x squared is canceled out with 1x squared. So the top, we're just left with 4 minus 1 over x plus 3 over x squared. Simplifying the bottom, same thing here. You have x squared over x squared. X squares cancel out. One of those goes, leaving you a 1. So the bottom, the first term is just 3 plus 2 over x minus 1 over x squared. And just like we learned before, any number divided by infinity equal to 0. So then all the terms with the variable x where we plug in infinity, they become 0. So 1 over x becomes 0, 3 over x squared becomes 0, 2 over x becomes 0, 1 over x squared also becomes 0. So then simplify everything, we see that the limit of this is just equal to 4 over 3. And just like the previous problem, if you remember horizontal asymptote rule, we notice because the highest power are the same, the answer just becomes the coefficient attached to that. So it's just a 4 and the 3. So again, we're looking for the highest power in the denominators. In this case, the highest power is x to the third. So then we divide every term by x to the third. So simplifying everything, see 5x to 4 x to the third. Well, all the x are canceled out, leaving you just 1x on top. The 2x to the third, our perfect cancels out. The x over x squared becomes 1 over x squared. For the numerator, we just have 5x minus 2 plus 1 over x squared. For the denominator, we do the same simplification. X cubed cancels x cubed. That's just 1. And the x squared over x leaves just 1 less x over, and the last term stays the same. So for the denominator, the first term is just 3 minus 1 over x plus 4 over x cubed. And just like before, plugging in infinity in, you see that the numerator 1 over x squared just becomes 0. The denominator, the 1 over x and the 4 over x cubed becomes 0. So now we have the function left over 5x minus 2 over 3. But if we plug in infinity for that, you have 5 times infinity is just infinity. Infinity minus 2 is still infinity. Infinity divided by 3, the answer is still infinity. So in this case, the limit of this problem is equal to infinity. Besides this limit to infinity problem, we can't exactly just plug in infinity in for x's, even though it looks like we can. This particular problem actually requires us to multiply it by the conjugate, which is the square root x squared plus 4x plus x. And of course, can't multiply out of the blue, so we multiply by numerator and denominator, x squared plus 4x plus x. And as you recall, when you multiply conjugates, you don't have to FOIL all 4 terms. You can just multiply first term and you need to multiply the last term. Multiplying the first term together, you'll get just a x squared plus 4x And then for the second term, the minus stays. And multiplying the second term together, you get an x squared. On the bottom, the denominator is just now the same denominator. From simplifying the numerator, we see that the two x squareds cancel each other out. So then this x squared and that x squared is gone. So then the problem simplifies to just having 4x in the numerator divided by the denominator. Now we can treat this like we treat previous limit to infinity problem. We find the highest power in the denominator. In this case, even though there's an x squared down there, it's actually the square root of x squared. So the highest power in the denominator is just x. So then we take every term and divide every term by just x. So when we take this term divided by x, the numerator divided by x. But when we go inside the square root, each of those terms are actually divided by x squared. And now we simplify everything. The top, the two x's cancel out. So we just have 4 by itself in the numerator. And the bottom, we have the square root of x squared, or x squared is just 1, plus 4 over x, and then plus a x divided by x, that's just a 1. Putting in infinity in for x, it's 4 divided by infinity over here, that just becomes 0. So now, simplify everything, we just have 4 over the square root of 1 plus 1. Well, the square root of 1 is just 1, so we have 1 plus 1, so then it's 4 over 2. So the limit then is actually equal to 2.